butterfly. If we get moisture on the ESC or the receiver, they're going to burn out. We learned from pickles that if you get the connection moisturized, it's going to explode the battery. So our station is RCDOX. This is our experimental aircraft, Neuron. Neuron can fly slow, fast, and crash well. And was partly inspired by the front wings of the monarch butterfly. The monarch butterflies are thermalin experts. They spread their wings and ride upon air currents. They also have to fly through the air so they can bring their wings back. This is our first version of Neuron. This is our second version of Neuron SKIPPY. This plane is like the awesome protected front plane. I crashed this like a gazillion 150 times, and look at that front. Now that the snow has come and it's winter time, it's hard to fly this version of Neuron. Problem that we have that the ESC and the receiver are like so out, you could like see them, they could not work anymore. The ESC and the receiver could get wet and they wouldn't work anymore. So we're going to build a neuron that protects them better. We're going to build Neuron with a blue Dow force. And then work over here. This is for insulating houses and you buy that at Lowe's. It costs about $1.60 a sheet. On one side of the slope, there's a little fill with plastic. This makes this insulation really good to build planes. You need about 1 1/4 sheets to build Neuron. We use a Uniball Vision Elite pen to mark our design. This pen is very good because if you want to break through the plastic film, or if you don't want to, it can do either one. Just like any other design build, you just start drawing some parallel lines on your piece of design. The really important line is the center of the line. It's about 1 inch in, and it's going to be for our vertical stabilizers. When the plane is sloped back. We drew a straight line, and then we kind of sketched in a curved line for the drawing. We did the same thing in the elevon right here. You only do half the plane, and when we cut this out, we're going to take that and move the other side and place that, so that it's the exact same. You want to have one this big and one that's this big. That would be a good plane. So now once you have your curves, cut them out. So once you cut that out with your X-Acto knife, you flip it over and take it to the other side. That's the bottom of our plane, and it's very flimsy. We flip our tracing over, then we lay it down on the sheet, then we trace the front, then we move it up, then we trace that. Double it up the whole way because we don't want extra weight. This is the most weakest part of the plane, so we want it to, like the whole thing to be strong. Even this part we want to try to get strong. This is the top part and this is the bottom part, and they are going to go like this on the plane. What's always very important is to keep track on your two center lines. That one's in the middle right there. No, right there. Like a butterfly, there's nothing straight on Neuron. Then cut your fins, and then make a compartment for your ESC, battery, and your receiver. You can tape on your elevon. The Scotch duct tape is good for hinges. Clear duct tape. This is a bubble holding pin that goes there and there. Let's glue it all together. Now with our neurons, we're putting in a little negative dihedral to hold the bubble. To put in the negative dihedral, we cut the bottom slit in the middle, and then we pushed it down, and then we put the hot glue in. We put the top, we glue the top piece and the bottom piece together, and then we put the fins in. And make sure that the blue film is on the top part and the bottom part on the outside. We're going to make this plain crash resistant because we're going to put dowels here and we're going to bend them down and hot glue them. So next then we'll be ready for the motor mount and then the electronics. This is my we did version 3 motor, and we're going to put it here. This motor mount was made by 1/4 inch plywood, and we're going to do it right here. This is my plane. My dad is going to slide and trim it, and then he's going to let me take over, and I'm going to fly good. I like crashing a lot, so we're building the front to be strong. Mostly everything is on. The motor is on. Most of the foam parts are on. The ailerons are on. Ailerons are on. The fins, the bottom shoe, and the fin up front. And we're almost done. I want to take a moment and talk about designing an airplane. For a plane to be able to stay in the sky, a force has to act upon it. The concept that has worked good for us is the air bubble. This air bubble represents a pressure gradient. The force is a pressure gradient or the air bubble. When you first build a plane, you gotta ask yourself, where are you going to put the air bubble? Where are you going to get the air bubble? It's pretty obvious on Neuron where the air bubble is going to come from. This whole bottom surface can compress an air bubble. Plane doesn't really have an airport, it's really just a flying door. See a hint of Klein Fogelman in here, but it's just to keep it so it doesn't really fall apart. If you would call this an airfoil, it would be a KSM2. A normal plane would have an airfoil. This is our ground takeoff plane, and it really has an airfoil. Airfoil is like an Epler 421. It's just the upper chamber of a 421. This airfoil can create a bubble in 2 ways. 1 by compressing the air like the Neuron plane, and 2 by the airfoil. The airfoil creates less pressure on the top of the wing. You can look at this chart and think of lift, angle, drag. This shows how a bubble is going to act on the plane. This is for a Clark Y airfoil. Power system on this is a combination from Grayson Hobby. If you're a new flyer, the combination deal is the way to go. 6x4 prop, Grayson Hobby microchip version 3, 20 MPSC. We're matching it with a 1000 mAh blue lipo from Hobby Parts. Dividing mAh by 1000 gives you 1000 mAh 20C battery. Multiply all by your C. This battery can give up to 20 amps. Our microjet and ESC need less than 20 amps. So this power system will work for this plane. We could put a lot bigger battery on Neuron. We float it with 1800 mAh batteries. Having a lighter battery, we minimize damage when we crash. It's very important to protect your battery when you crash. There's the little cookies fat for like batteries. We're going to put some foam that came from a motor box and put it in this little slot. That'll help cushion the battery when we crash. We're using TPO servos from Hobby Parts. These are 9-gram metal servos and they're $7 a piece. I can do it. Our control arms are from Grayson Hobby and they're 95 cents a piece. We made our control arms out of price. We're using our V-tail mix receiver from the Jet Tiger. Now we're ready to finish this plane by putting on our electronics. I don't have a name for this plane yet, but I'm hoping that it's going to be Crash Monster. This plane is the first plane that we built for winter flying. Hi, we're RCDOX. This is my new Neuron plane that I decided to call Snowflake. We got a box of controls. We're going to put a piece of foam over this, and then tape it here, and then going to draw eyes here, and try to get a smiley face here, and then draw a big snowflake in the back. On this plane, I'm going to work on my praying blade barrier.
A little more power. Pull back a little bit to the right.